This is Unit 8, and we're going to discuss graphing in Unit 8. Our learning target for Day 1 is I can make a table and graph a linear equation. It's very important during the video that you have either coordinate grid paper or graph paper as you follow along. So please grab that and then turn the video back on. Our vocabulary term for today is linear equation. And right now we're going to discuss what a linear equation is. Let's review briefly on graphing. So on one coordinate grid, please graph the following points. 2, -1, and mark that as A. 3, 1, and mark that as B. -2, 2, and mark that as C. And -1, -3, and mark that point as D. So let's see how you did. Here is point 2, -1. Here is point 3, 1. Here is point -2, 2. And here is point -1, -3. Okay, so now we're going to define what a linear equation is. You see a visual here with the graph, and this line tells you that it's a linear equation. So the graph is a line, that's the first rule. And second of all, when you look at the equation, you see two variables in the equation, and they're both to the first power. In other words, this is y to the first power, and this is x to the first power. So that's also important to have a linear equation. It's also important that x and y are in different terms. If you remember back to what a term is, in this equation there are three terms. Y is a term, 3x is a term, and 1 is a term. So there are two different variables. They're both to the first power, and the variables are in different terms. Here are some other examples of linear equations. Y equals x minus 1. 3n plus 4m equals 12, and y equals 6. Now the reason y equals 6 is a linear equation, even though there's only one variable, is it's similar to y equals 0x plus 6. So this is almost like the simplified version. Okay, so here we have an equation. It has two different variables. They are in different terms, and they're both to the first power. So this is a linear equation. Take a look at this equation. Is this a linear equation? S equals 2/10 times P. Yes, it is. And here we have another one. 24 equals R times T. Nope, it's not. And it's not because both of the variables are in the same term. So here are 4 for you to try, and then we'll move on with our video. Okay, there are 5 steps in graphing a linear equation, or graphing any equation. We're going to make a table, and we're going to choose x values for the table, and then we're going to put in the x to find the y. So it's always smart to start with some negative terms and 0 and some positive terms. So that's what we're going to use today. So we're going to plug in x to find y, which means we're going to evaluate y for each x. We're going to plot the coordinate points, the xy terms, and then we're going to connect all of the points with a line, and remember our arrows at the end, because all lines go on to infinity in both directions. So let's start by looking at the equation. It's definitely a linear equation because there are two variables. They're both to the first power, and they're in different terms. So let's make a table. Now we can make a table vertically or horizontally. It doesn't really matter. So I'm going to put in my x and y terms, and then I'm going to substitute in -2, -1, 0, 1, and 2. And then I'm going to put -2 into my equation to find out what y is. So I'm evaluating y for each x. So if I substitute in -2 here, I'm going to get 1. So I'm going to put 1 in for my y term. If I substitute in -1, I'm going to get 2. So I'm going to substitute 2 in, and so forth. So now I have made a table and chose my x values, and I've gone on to step 2, which is evaluate the y for each x. So I stuck x into the equation to find what y is. Okay, now this is the table we created. Now we're going to plot each point. So -2, 1 is one of the points we're going to plot, and that's how we choose the points from our table. So here's our coordinate grid. I'm going to plot -2, 1, and -2, 2, and 0, 3, and 1, 4, and 2, 5. So now I have plotted each point. I'm going to connect them with a line, and I need to remember there's arrows on both sides. So let's review. The first step was, when you're working with a linear equation, create a table with x values, and then secondly, plug in your x into the equation to find your y. Third step is to plot each point, then you connect the points, and don't forget the arrows on the ends. Okay, so let's look at this problem. Now, notice for this one, it's still a linear equation. There's 2 variables. They're both to the first power, and they're in different terms. So I've picked -6, -3, 0, 3, and 6 because I'm multiplying by the fraction 1/3. So I wanted to multiply by a multiple of 3 to get rid of my denominator. Then it'll be easier to graph. So here when I substitute in, I get 0. When I substitute in -3, I get 1. When I substitute in 0, I get 2. When I substitute in 3, I get 3. And when I substitute in 6, I get 4. So now I'm going to graph each point and connect each point with a line and remember my arrows. Okay, here it says a hot air balloon is 5 feet off the ground and starts rising at a rate of 2 feet per second. The height h in feet of the balloon can be found with h equals 5 plus 2t, where t represents the number of seconds. So this is my linear equation. I have 2 variables. They're both to the first power, and they're in different terms. It could also be similar to y equals 5 plus 2x. So first we're going to create our table. If the balloon is rising, we're not going to have any negative numbers. So I'm going to start with only positive numbers. So 0 would be the feet off the ground. In other words, it's touching the ground here. And then number 1 would be it's 1 foot off the ground. And number 2 says 2 feet off the ground. So if we plug in our terms, we know if it's 0 feet off the ground, the height is 5 because the hot air balloon is 5 feet off the ground. That's where it starts. And then we're going to substitute in each of the other terms. And now we have our coordinates to plot. So here's our grid, and I've labeled our height in our vertical axis and time in seconds in our horizontal. And I plotted my points. And then I'm going to connect them with a line and remember my arrows. So here's one for you to try all on your own. Y equals -2x minus 3. So you're going to make your table with x values. You're going to substitute in your x values to find your y's. You're going to plot the points and connect the points with a line that has arrows on both ends. Last, tell me something that you learned or were reminded of and a question that you have.